Okay, so let's see the product in action. Before I get started with the demo, just a couple of things. We are launching Platform 2.0. Actually, we just launched Platform 2.0, the Cloud Native Visibility and Security Platform. And the two key new introductions to this is a unified overview application that brings together monitoring data, telemetry, along with security insights into one platform to help triage issues faster, and I will demonstrate that. And the second most important thing is 10x increase in scale. We've been working for over a year on re-architecting our backend to deal with the kind of metrics explosion that's happening in the market. With Prometheus, Prometheus is an example, good example of high cardinality metrics, and how we are dealing with that. We're introducing our new scalable metric store, which can ingest and let you query up to hundreds of millions of metrics per second. So this is what's new, but we're going to show you the whole product as a whole. And just to keep this in mind, we are going to show you how we're going to focus on 4 use cases from the lens of some of our key personas, one being the security team or a security operations person. And I'm going to show you something where you're talking about how does it tie into a SOC. A DevOps or an operation person who's standing up a Kubernetes platform or a containerized platform, and what insights they need, how do they do capacity management and ensure that their environment is compliant. And a service owner who is deploying their application on this platform and what sort of insights they need. And take you through the full, how Sysdig helps in the entire lifecycle management of a cloud native app, from when you're building to running to responding, which I think we've already touched upon earlier, so I won't go deeper into it. So let's jump into the demo. Just give me a second as I transition. All right, so you have set up an environment. You have a cluster of containers. A Kubernetes cluster. You've deployed somewhere. You deploy the agent as a daemon set, and you come into Sysdig, and you will see that we have auto-discovered all your hosts and the containers that are running within this host. So this is sort of a mesh of hosts, and if you drill down, you can actually see all the containers that are running within that host, and how they are connected, how they are talking to each other. This is the physical topology of your entire infrastructure. Now it gets interesting. This can get pretty gnarly, right? So what is interesting is applying service vision to this data, which is where you apply your labels and metadata and start looking at it from a different lens. That is my applications and my microservices. So now you see it's completely simplified, and I'm looking at 2 clusters here, one which is running on Google, GKE, and the other which is running on an OpenShift environment in AWS. And we've discovered the cluster and all the applications that are running within it, which are in Kubernetes world, you can say namespaces that are running within it. And you can drill down from the cluster level to the namespace level. You can drill down further from the namespace to see all the workloads or deployments that are running within that namespace. You can drill down to the pod level, which is a unit of work that's going on in your containerized environment, to your container, and down to the process that's running within that container. So this is like the Google Maps of your infrastructure and services. So you went from a very high level of knowing which service is talking to which service. When Suresh was talking earlier, it's important for users to find out in this dynamic and ephemeral world who's talking to whom. Then these containers could be coming and going in few seconds, but we always can maintain that service level view of the world. The most important takeaway for this is, in order to build such a topology today, you would need code instrumentation with most tools out there. We are not doing it with code instrumentation. Because we are at the kernel level and we can detect which process is talking to which process, we are gathering that information and we are building this topology ground up automatically. And then we are overlaying, not just building the topology, and then we are overlaying metrics on it. As you can see here, I'm looking at response time. So we are overlaying golden signals that are needed by most application owners, like response time, throughput, error rate, and various other metrics. You can overlay any system metric. You can overlay custom metrics that like Prometheus metrics. You can overlay your compliance results. Right? One of the use cases I was looking at the other day was like, hey, I need to know which containers are running as root because they're not supposed to. So you can overlay that metric and see which containers are running as root and who else they are talking to. So this is service discovery automated the Sysdig way with no instrumentation needed. I think there was a question about Istio. We can back this topology with data that we get from Istio as well, where you can, Istio emits Prometheus metrics, and you can pretty much, we automatically detect all Prometheus metrics, so we can get that metrics and the labels and overlay this on this topology. So you would be able to see your service mesh as well.
Sorry, you've got your namespace structure organized by application, but say if you had a namespace that was shared by multiple applications,
yeah.
So you've got things with different labels in
yes.
there. How would that be exposed?
Good question. You can basically create this hierarchy. So here I have cluster and namespace. I could choose any label that I want. I could have created my own custom tag or label that I have created. So we have, for example, we have customers who are organizing it by image tags. So they've taken a group of container images and said that, okay, I'm going to tag these container images, and that's my definition of an application. So you can customize this hierarchy with any label, all container labels, host tags, what have you. And this is our service vision, right? You have the raw data, and then you're stitching that data with any sort of labels to build these hierarchies. So we obviously presented a very standard, this is our out-of-the-box view, and which is, okay, cluster, namespace, deployment services, stateful sets, pods, containers, but you can customize that. Okay. All right, so I'll move to the second, so this is service discovery. So let's look at the day of some of our key users. So let me introduce you to this new overview page. What you're looking at here, again, this is the cluster level view. You're looking at a combined unified view of risk, health, and performance. So you will see here key KPIs for your cluster, like allocatable, how much you're using versus the capacity you have, availability, so you're getting availability performance, as well as compliance results, right? So as a cluster operations person who is responsible for managing their Kubernetes clusters, they can get all of that information in one place. You can also, this list, you can drill down from here to the different levels, and I'll show that to you in a minute. But this list gets sorted by the events that are happening on this cluster. So imagine when you have hundreds of services, or you have thousands of nodes, where do you know there is a problem, and what problem is it? So this is a place which helps you triage the issues. And on the right-hand side, you see a combined event stream of things that are going on. And this combined event stream includes events that are coming from your health monitoring alerts, like CPU is low, or you're running out of disk, or your response time is slow. It comes from scanning, like, okay, you have services running containers that have known vulnerabilities in it. Security events that are based on policies, where you have defined, you're not allowed, this service is not supposed to talk to any other services beyond this set of IPs, and somebody violated that, or somebody did something suspicious that they're not supposed to do, like spawning a shell. Your Kubernetes events, like something's failing, your pod status.
I have a quick question for you there, sorry. Where can I send these for maybe alerting? Like, can I have ServiceNow tickets generated, or
yes.
text message services, or those sorts of things? I can integrate that, yeah?
Yes, you can send it to various different avenues. basic like email, Slack, PagerDuty. We have webhooks, so we have people using webhooks to sending to wherever they want. ServiceNow is a good example. We can forward these events to a CM tool like Splunk or Syslog, and we also have native integrations with some of all the cloud platform security hubs like the Google Command Center, Security Command Center, or AWS Security Hub, and all of those as well. So you don't have to sit and stare at this view. You can get a notification and you can jump in as needed.
The Splunk forwarding, for example, when you're going to SIEM, is there filtering to say which kind of alerts and things you want to send to that? Yeah.
You can send by certain scope. Like, okay, I want only to send alerts from production.
Or I only want to see failed authentication attempts.
Yes.
Or, yeah.
Like severity.
Yeah.
Yes, exactly. So there are certain properties on our events, right? Severity, type of event, like the status, like you can see here, right? Like different types of events, have they triggered, resolved, or you can set scope on this, or have certain keywords, so you would be able to do that.
The compliance piece there, is that your own rules, or is that based on CIS?
CIS benchmark. So I'm going to dive and show you a scenario where we go into. So I was just introducing you this overview page where we are bringing in information, breaking the silos between different tools, and reducing operational overhead for somebody who's managing this platform, right? So right from here, so I say I'm going to take you through the compliance scenario since you asked about it, and then we will go into a forensic scenario. So I'm looking at this cluster, and I see there are some compliance violations. I can go drill down to the node level and see which nodes have compliance violation. And from here, I can launch directly into the Docker compliance report. So when I launch into the compliance report, so we are running these CIS benchmarks. Hope it comes up. All right. So we're running Docker CIS benchmarks, Cube benchmarks, and here you can see this is the benchmark that was run, and I observed that there were change in ownership that they're not permitted to, and that's why it raised an alarm. And we will also suggest a remediation of how you can solve that problem. This is a simple one, but as you can see here, we have various different types of rules, right, that we can look at, and this is the standard compliance. So now I have detected that somebody changed this ownership of etc Docker. Now I want to go and see who did it and at what time was this done. So I'm going to go straight into what we call commands audit, and just change the time frame. So this is where we see every single command that was executed on that machine, and executed every command stroke. So I'm going to look for etc Docker, and I can see, right, somebody did change it, they VI'd into it, and I can even find the user ID of who did it. So it was done on 4/4 at 7:15 a.m. and here's the user ID. So a few clicks, I'm able to get a cluster level compliance report to which node where the problem was, which container, and which user did that at what time. So that's the first scenario. Now, there are, as I think somebody was asking about PCI, there are other ways of ensuring compliance. One, of course, is you can write your own several policies. So we have a pretty flexible policy engine. This is a part of, if you've heard of Falco. Falco is our runtime detection engine that's a CNCF sandbox project. And you can write pretty detailed rules for your policies. And at the file level, network level, process level, container level, syscall level, and for Falco, custom rules that you can write with Falco. And when you trigger a policy, you can set the policy on a certain scope. So again, here we bring in our service vision to say, okay, set this on production. I may have a much more lenient policy on dev versus production. So you can say that I want this to run only within this namespace, so you can set a policy by different labels. And then you can take actions, as for example, you can stop the container or pause the container, or capture more information during that time, and I'll go through that scenario as well. The third way where you can ensure compliance is just ensure that you don't have vulnerable images going into production. So we do full image scanning where you can hook up with your repositories and you can define a pretty flexible set of scanning policies for your images, and they're not just at the OS level. As you can see, it's pretty flexible on how you can how granular you can get with what's permitted in your environment and not. So, so we talked a little bit about scanning and compliance. So let's come back to this, and we're going to do a troubleshooting scenario or a forensic scenario. So, so imagine I'm going to switch gears and assume I'm a security operations person, and yes, I'm probably not sitting and staring at this event feed. I'm probably looking at Google Command Center. That's the Google's security hub. This is the GCP platform, as you can see, and we have a native integration there. So I might be getting the events from there, or if for simplicity, or it may be in Splunk or somewhere else. But let's take this example, and I see there is an issue. I'm going to start digging deeper into terminal. Somebody spawned a terminal shell and what's going on there. So the first thing when a terminal shell, this event has happened, the first thing is, of course, where did it happen? So it shows me it happened on this particular namespace, deployment pod, the host, container information, the image, and it gives me a little summary of that a shell was spawned in a container with an attached terminal, right? So the next thing I want to do is look at, okay, so this container base is gone after this policy was triggered. And the part of the policy was, just pause that container or kill that container if something like that happens. The container is gone, but I want to go back in time and look at everything that was executed before this violation happened. So I'm going to go back and look at command history. And here, as you can see, somebody bashed, uploaded a file, removed it, untarred it, and then shredded it, unzipped it and zipped it and shredded the bash history, right? And you can observe the name of that file, vlanY master. So now I have a capture of every single keystroke on that machine before that violation was triggered, and this is going back in time. The container is gone, and you can still go back and look at it. Now, that's great, but I still want to dig further. I want to know what this vlanY master rootkit is, and what else did it modify, what did it touch. I want to dig deeper. So Sysdig, dig deeper. So now comes the magic of what Loris has created. We're going to look at what we call a capture file. So a capture file is captures every single system call that was executed during that period of time on a machine and stores it in a file, and this happens on a rolling basis. So if something happens, we store that file. If nothing happens, we discard the file. You can choose how much you want to do. So very clearly, I have a notification. I have accessed files and modified files. Now I see there is a pattern evolving. This is where things are happening. I can look at other things like network activity and so forth. So I'm going to drill into this time frame and look at this. We're looking at a 2-second time window. So we're really going down to a nanosecond, microsecond level of granularity.
But do you have to, sorry to interrupt, do you have to actually select the outliers you want to see?
Yeah, yes. You can select a few key, you will see the anomalies, right? Because you can see the spikes here, right? So you'll observe the anomalies. And here I'm going to look at what files were modified.
Sorry, can I just make a suggestion that you add some better coloring to that so it's easier to see?
Thanks for the feedback. We have a lot on our roadmap to do, and that's something we want to improve. We actually want to improve the that aspect as well on the user experience. So here I am, and there is my vlanY master file. I can figure out every file that it has touched. I can even look at, let's say, the README file. Actually, should just expanded this, and even see the contents of the file.
Can you, I noticed that in your UI, there's a area at the top labeled Sysdig filter. Can you compose these queries cold? Is that a syntactical language or a DSL of some kind that I could compose these queries and query the backend in batch, for example?
Yes.
That is right.
Yeah.
Yeah, I'm just asking because, you know, a SecOps team may want to run queries, historical queries on a set of expired containers, right? And, you know, if you can you build this query and then reuse the language, if you will, then you've really got something.
Yeah.
Yeah.
How big are these SCAP files, just in general? Like, how much storage space do you have to allocate if you're running, say, like 100,000 containers or something?
So, the way we do this is, of course, this is data with such granularity and needs to be collected at the endpoint, right?
Right.
So what we do is we simulate a packet capture appliance in every single endpoint by reserving an amount of memory to have a circular buffer. So these events constantly go in a circular buffer. So when you have something like this, a terminal sharing container, we can give you not only what happens after that, but also what happens before that by using this buffer and essentially uploading it somewhere. The size of the buffer is typically 100 megabytes in memory. It's a parameter of our agent, so you can make it smaller or bigger. Typically, my experience is that such a size gives you something in the order of minutes, right?
Okay.
From tens of seconds to minutes, depending on the activity of the machine. If you want more, you sacrifice a little bit more memory, essentially, for Sysdig.
And then that information is being sent up to either your cloud service or it's being sent to whatever local service
exactly.
backend you're running.
So essentially, you have three ways. One is you click a button and you take this buffer and it's uploaded. The second one is you use an API. And the third one is you tie it to an event. So one of the events, like a terminal sharing container, can trigger one of these and triggers the upload of a file related to the event somewhere. And then when you see the event, you can navigate to the file.
Okay, so it's not constantly uploading every container.
No.
It's just when it sees an event,
Yes.
now it's
Exactly.
saying, I want to grab what's in that circular
Exactly.
buffer and export
Because
it.
that
for
would be
use.
megabytes a second per container. You know?
Where are you storing
Yeah,
all that?
exactly. No, it happens. We do that. We always do that for a limited amount of time on every machine, but then we upload only when something happens.
Okay, that makes much more sense. Thank you.
Yeah.
And so how long are the files retained for?
As far as I know, forever.
Forever, it's up to you.
But you guys correct me if I'm wrong.
Yeah, we have customers that'll send them to their own S3 buckets, and then depending on the severity of the policy violation, they might have different retention policies for those captures.
Yeah, that's right. And we have customers who are even segregating based on, like, if, let's say it comes from they're serving multiple customers, so they need to isolate these capture files because they might contain information. So different S3 buckets for different end users or different namespaces or projects or applications or what have you. Cool. So
It's fine.
jumping to the last scenario. Sorry, you have a question?
So I'm just interested at this event you have on the port opened on TCP. So just from my own understanding, you're above the TCP stack with eBPF,
That is correct.
but below the layer 7 encryption, right?
Correct.
Okay, good. I'm just trying to understand. So you wouldn't see things like TCP window size changes and that kind of stuff?
We won't see things like TCP window size changes. For example, an open port we detected by looking at the bind code, you know? So we see a process doing a bind on a specific port.
Got it. Very interesting place to be, though.
Yeah, exactly, because it gives you sort of a, like an intermediate layer between layer 7 and decryption. Will make announcements related to that in the future, and being like at the TCP stack level.
It's not a common place to be.
Yeah.
You know?
This is the way.
Yeah, that's what's different, yeah.
Okay, I'll continue with the last use case, and this will focus a little bit more on monitoring. So we showcased you compliance, scanning, runtime detection and forensics, and now we'll show you a little bit of monitoring and troubleshooting. So again, now I'm going to assume the persona of a service owner or an application owner who is deploying applications, cloud native applications on this platform. And let's say, I mean, we're calling these namespaces, but as you know, it can be organized in any way or any label as you may need. So I own a ticket, I own a few applications, and ticket backend is one of these applications. By the way, in Sysdig, we have inbuilt teams, and you can, what that means is you can isolate the data in different parts of your application. You completely isolate the data based on the scope, or for example, as an application owner, I want to only look at X. I have only permissions to look at these 4 applications. We will automatically be able to create those teams for you with the right permissions and map it to a user base that has permissions to see that data. So so I look at this and I see that I'm going to drill down to all the different services that I'm looking at. See ticket server and backend. Again, this is a very simple application, but if you had thousands of services and deployments, it filters to the top, the ones which are the most important. And I can see some key golden signals like latency and errors, as well as some of my use signals like CPU memory and pods desired. So I see that I do not have enough pods that I need to run my application. And if I click on this, I can see a few events going on right after a deployment happened, trying to scale the replica set, but there is some failed scheduling that's going on. So from here, I can go drill down into some of the inbuilt dashboards we have, or a custom dashboard you may have created. And this is where we bring together data from various sources. So you can see your golden signals like latency, request, error rates, Kubernetes information, pod status and capacity. You can see that there are pods unavailable. The CPU, memory, storage, network, application metrics like JVM, or any other application that's running within the container. So the power of Sysdig is metrics are auto-detected. You do not need to go configure and tell Sysdig that this is a service that will use JVM, so you need a JVM plugin or a JVM configuration. Because we are at the kernel level, we are automatically detecting those system calls. We detect that it's a Java process. We can do pattern matching, and we extract all the metrics and give you dashboards out of the box for you. So imagine when you are managing a platform where services are being onboarded and they're using new technologies that you may not be aware of. You don't have to worry about it because Sysdig will automatically discover that and give you a dashboard for it. So here it's a simple example where I can see my cluster is quite close to capacity, and if I've specified some resource limits and requests on my application, but my application actually doesn't even use that much. So if I reduce the requests and limits, I would be able to free up the space I need to let it have enough pods that needs to serve up the request. So that's an example of a scenario. But as I said, we have, for example, in Sysdig, you can look at various different dashboards that we give you out of the box, whether it's cloud platforms, applications, container hosts, Kubernetes network, topology, custom metrics like Prometheus, StatsD, JMX, again, all auto-discovered. And that's the Sysdig way, right? Auto-discovery of your services and auto-discovery and of all the data that you need to build, to solve some of the most important use cases. So that's it.
Do you have anything that's kind of working out what normal is or what healthy is, and then kind of showing you where you're deviating from that?
Yeah, so we have anomaly detection alerts. So when you set up an alert in Sysdig, you can, when you set up...
I mean, less kind of in alerts, like in the dashboard there, you're going like disk usage is 12.6%. Like, is that good? Is that bad? Is that normal? It's a pretty number, but how do I relate that to if I've got a problem or not?
Yeah, you can, we have functions that you can apply on that instead of looking at value of risk disk change, you can look at like rate of change, how fast it's changing. So you can apply certain mathematical functions similar to what Prometheus query language does. It's the same query language that we use as well, where you can predict or look at trends. And we have, we have what we have in alerting, and there is a project that we are working on a little bit more futuristic project on anomaly detection.
So today it's statistical. I think if you're asking, do you learn behavior and look for anomalies based on learning?
No.
That is not yet in the commercial product.
Because you've got all this data, you're pulling everything in, but to make sense of it, like you want to kind of make it as simple as possible and just kind of go, we don't know if you've got a problem here, but this looks different than what you may have changed your pattern. You may be Black Friday or whatever, but otherwise it's hard. You've almost got too much data to like.
It is way too much, and I'd rather just know, okay, this is a deviation from normal, or I want to know a strong correlation between, we're seeing issues on the back end, like maybe a cloud region has some issues, and we're seeing high latency on this application.
Indeed.
If you can strongly correlate them, then you don't need to wade through all of that info. And it's pretty easy for systems to surface up, okay, there's a correlation here.
Indeed, and that is precisely sort of not, so today as that's right. There's the rich source of data that you can do a lot with. Part of our sort of something that we spend a lot of time is on where do we draw the boundary before part of the challenge is, you saw the picture with Loris where he said packets and then a dozen different things. I'm petrified about how many we keep adding on a daily basis versus where do we want to really be definitive about what we do. And that's a big part of what we need to be mindful of.
If we
certainly learning is a big opportunity area with the data we have.